Hello, my name is Thomas Rodriguez, and I will be going over Lab 2 for Physics 2211. So to introduce my lab, I compared three models of dropping an object from a certain height at rest. I had a real-life model, a computational model with just gravity, and a computational model with gravity and drag considered. And the purpose was to determine which of the models would have the object go at terminal velocity. I have three fundamental physics principles that are involved in the lab. First is the gravitational force, so that the force of gravity on an object is constant and acts downward at 9.81 meters per second squared. Then there's Newton's second law, which can be represented by F equals ma. And then there's the momentum principle, where it's represented by P equals mv. So both the second law and momentum principle demonstrate that that terminal velocity is when f would equal 0 and therefore acceleration is 0, and that the velocity would be constant when it's at terminal velocity. And then of course the gravitational force is just because one of the forces going down and acting on the object is the force of gravity. A brief preview of the main result was that the object reached a terminal velocity in the computational model with both drag and gravity, but not with the computational model for just gravity. So some assumptions I had was that there would be no outside forces, the object would have a constant mass, and if I did it correctly, the object would fall in a straight line. And as for the models, I had position versus time graphs, and I also had, in the computational model, velocity versus time graphs. And the initial condition was that the object's motion would start at x equals 0 when time equals 0. For the system, it was just the object, or the tissue folded up into a ball. That's what I used as the object. And for my surroundings, it was the hand releasing the ball, the force of gravity, and air, or like the air resistance. So this is a video that I put in the tracker. And then this is a screenshot of my tracker model. So this is the actual graph. As you can see, over here was the position was slowly, or the velocity was increasing until it reached a constant velocity. So this is the computational data for gravity. I set the position to 0.8, like in the real-life model, where I set the height which I released the object was 0.8 meters, and I set the proportionality constant to 0 because that models for when there's only gravity and no drag. The time was the same as in the real-life model, where it was ended at 0.533 seconds, as shown here. And then this is the code that I used to calculate for the net force. So I solved for F gravity and F drag separately, and F net is the sum. And then I calculated for the velocity of the ball and the position of the ball. So this is the computational data for gravity and drag. So I just changed the proportionality constant to a non-zero value so that it would end at 0 over here. And the difference between the one with gravity and the one with gravity and drag is that the one with gravity and drag, you can see that it's slowly reaching this terminal velocity in the one with gravity and drag. But here, the velocity is constantly, it's like decreasing, but it's like constant. So it would be like a constant acceleration, but the velocity is changing. So my conclusion is that some possible errors were that in the real-life model, it was kind of like, it was going constant here, but then it wasn't really constant there, so that could have been an error on my part. And also the ball felt slightly to the right, so it wasn't exactly straight down. I predict that the one with the model with the gravity and drag is the one that has terminal velocity, but not the one with just gravity. And also, for this question, with the terminal velocity in this case, if the object was initially thrown downward, would it be the same or different than when the same object was initially dropped? And I would say it's the same, and I modeled it through the computational data. So this is when it's initially dropped, and this is when it's initially thrown down. And as you can see, for the velocity, they both reach a terminal velocity. And that concludes my lab.